Good day everybody and welcome back to the channel. I got a new bit of kit here to take a look at, so I thought I'd do a video on it. It's the same transistor tester that I've forgotten the bloke's channel name. Tony, he fixes amplifiers. Anyway, he got one of these. I saw him using it, was impressed with it, so I got one for myself. Just thought I'd show you guys what it's all about. So it doesn't do too much more than the Atlas. I mean, it doesn't do all the curve tracing and stuff like that, so it actually does a lot less in that regard. But where it's caught my attention in two areas, right? And one area is actually quite interesting to me. Actually, before I say what I'm about to say, let me just say something. When I do the HFE test on this, I'm not sure what it's doing in terms of collector current, base current, base 1 milliamp, base 5 milliamps. Oh, collector current 5 milliamps. Base is 1 milliamp. Alright. So the thing I find interesting is that's not saying 97 HFE, right? At 1 milliamp base. If I put this on 10 microamps base, PNP, the right position, I'm getting 91. If I go up to 1 milliamp, I'm getting over what that shows me. So a bit of a discrepancy there, but it's pretty cool that I can look at 10 milliamps versus 1 milliamp versus 10 microamps. Right? That's pretty cool. This thing puts quite a bit of current through the device too, to mention. I mean, it's not just feeding in 1 milliamp into the base emitter junction and that's it. It's definitely putting current, whatever the transistor wants to pull, across the collector emitter junction. I can tell because when I stick it even on 1 milliamp, put it in here and feel it, the transistor gets bloody hot. I can feel it warming up. It's getting quite warm now. Alright, that's now warm. If I put it up to 10 milliamps, it'll actually get hot. So, yeah, that's hot. You can see the HFE climbing. So that's cool. We can, test larger devices and see what the current's going to be like. And as I showed in a previous video, that's quite useful. For example, at 10 microamps, right, 97. The counterpart, 107. You might think, okay, they're not too good. At 10 milliamps, 81.4, 81.5, 73. They're only about 8 apart. So, it's quite handy for seeing what transistors are doing at different current demand areas, if that makes sense. That is very, very, very handy when you're building an amplifier because, when I'm designing an amp, I know what transistor in what stage is taking how much current. So I can have a look and see how well matched they are at, the amount of current that's going to be going through them. Obviously that varies depending on the volume of the amp, but you get what I'm saying. Okay, so other things that we can do on here. We can test leakage. So you can actually do a few different leakage tests. It's all written in the book here. It actually shows you, here it is. So you can see in the different diagrams, ICEO, ICBO, IEBO, diode reversed ICEO. That's for reverse leakage, testing between leakage between collector emitter, collector base, emitter base, you know, and you just use the collector and emitter jack on there, you know, and just only put 2 legs in at a time, for example. I can do this to show you, no leakage, and then you press that button and it will test it. The other thing this can do is it can build up to 1600 volts, which is pretty good. That's for voltage breakdown testing. So if I put this guy in there, test it, 320 volts, right? If I take a fake one, by the way, these are MJ15033s and MJ15032s. I have real ones and I have fake ones here. If I take a fake one and put it in there, 130 volts. Well, that's quite different, isn't it? There you go. So something else you can test is, we'll come back to the breakdown in a minute, VC sat, so saturation voltage. You can test that at 10 milliamps collector current, 100 milliamps collector current, 800 milliamps collector current, or 2 amps collector current, which is quite nice. So we'll take the fake one first. 10 milliamps, it's 002, 100 milliamps, 004, 800 milliamps, 019, 2 amps, 044. The real one, 046. I already did this test before, and I got to say, it's scary. I mean, I pointed this out in a previous video, and I've actually got some transistors to show off to the side. But remember, in another video, I took tip 41 and tip 42 transistors and a few other parts that had very small dies. And when I say small, that's how big a tip 41 die is supposed to be, right? But the fakes will have something like this inside it, even smaller. And the thing that scared me is I did some testing, quite a bit of testing, and the scary thing was that they somehow dissipated their rated power. I don't understand how. They probably won't last for very long, but the fact that they're even holding up at all scares me. This scares me as well, because as we can see, this fake thing, which we've looked inside this in a previous video, the die in that is less than 1 millimeter big, and the VCE SAT test holds up, the HFE test holds up, voltage breakdown doesn't hold up, and physical inspection doesn't hold up. But yeah, anyway, just be careful, guys. These fakers are getting quite good at what they're doing, you know. Even these transistors here that I have, these are, if you can't tell looking at the packaging, the same thing. These are not real original parts. These are clone jobs, but these are proper clone jobs. These are not when the Chinese try and copy a real device and do a shit job at it and put a small fake die in it. These are actual copies made by a Chinese manufacturer, if that makes sense. Not dodgy in any way, just a little bit cheaper. I pulled them apart and curve traced them and everything, and they check out, so all good there. Anyway, continuing on with our tester here. So VC SAT, back to breakdown. You can actually test for, let's see. So you can use it to test field effect transistors, JFETs, MOSFETs, I guess. I don't know about JFETs. No, you'd probably, yeah, you'd kill the JFET. They're way too sensitive. Anyway, MOSFETs, LEDs, triacs, insulation of electrical appliances. Apparently you can, I mean, yeah, it puts out 1500 volts, I guess. If I was going to use it as a mega, I'd recommend getting one of these things and using this as your mega. This thing can do 3,500 volts. You know, most megas go up to about 4 kV. This basically is a mega. This is great for doing insulation testing, leakage testing. But yeah, 1500 volts is still quite good. Anyway, you could use it for that. You can also use it to test the withstand voltage of a capacitor. Thyristors. What? That's hilarious. They actually say that you can use this as a power source. That's hilarious. Oh my goodness. Anyway, that's funny. Oh yeah, that's the other thing it can do. You can test 79 and 78 series voltage regulators on this, which is pretty cool. I'll just go grab one. I've already tested it out, and yes, it does work. So I'll get a negative series regulator, I'll put it into the 79XX spot, turn the regulator around and put it in those holes there, and $5 volts. So, you know, it's not too bad. It's quite a useful thing. It outputs about 27 volts in that mode. I'll just show you guys what it does in different modes. No, it's going to be between 1 and 2, isn't it? I might just get something else to stick in there. That's all right. I'm not going into the metal contacts and breaking them, but I am ruining the top a little bit. Oh, come here. Oh my God, come on. I'm trying to grab these little bits of wire out of a container and I just cannot for the life of me get it to stay in my hand. Come on. All right. So there you go, 33.7 volts. Quite cool. That's very handy for testing things. The capacitance test socket, not for measuring the value of a capacitor, for breakdown voltage testing. Nevertheless, 240 volts DC there. And okay. Oh yeah, that's right, 1600 volts. Duh. So pretty cool. What else can it do? I'll just pause the video and have a quick look in this book. Nope, that's it. I just wanted to double check because I've only owned this thing for about 3 days. So although I have read the book and I've been using it, I thought, you know, I might be missing something. Its claim to fame for me, and this is where I really like it, testing HFE of a transistor is as simple as just, you know, that's great because well, look, 140, 105, right? If I want to use this, I've got to hook my leads on. Even if I've got a test socket hooked up, I've still got to put it in the test socket, put the little arm down, hit the button, wait. You know what I'm saying? So what do we get there? 163, 140, 178, 1 milliamp. It's not far off. Anyway, that is very handy for matching a whole batch of transistors all at once. And I've already used it for that purpose and it was wonderful. I really like it. So yeah, I would recommend getting one. They're about 50, 60 bucks, something like that. I can't remember exactly, but it's not too expensive. It's definitely worth the money. If you don't have a ton of money, maybe get one of those instead of the DCA Pro. If you got the money, I'd recommend getting both of them. They both do different things. But yeah, I'm impressed with it. Now, you know what we're going to have to do in this video, of course. Of course, we're going to have to pull it apart. I can't leave you all hanging wondering what the build quality is like and what everything inside it looks like. And, you know, I haven't looked inside it myself either. I might take the cover off now and go, oh, that's terrible. I want to tidy up the soldering or tidy up the wiring or something like that. Who knows? So let's have a look. I've peered in through some holes under the batteries where the batteries go in. I'll show you what I mean in a sec. That is the only thing I have done. And I could see some cement, like wire wound power resistors through the hole. Obviously that's for sourcing current for the test subject. So it only takes 4 AA batteries. There is extra slots in here that don't have any contacts on them. Alright, I'll go get a different screwdriver, still Phillips head. I don't know if you can see on camera there, but yes, you can see the power resistors inside. Alright, I've got a screwdriver that fits down in these holes. I'm curious to see, is it like a, what do you call them? ICL 7100 or something, 7102. Those chipsets for doing your own digital multimeter. I can't think what they're called. ICL 7102, 7104, something like that. I'm wondering if it's sort of based off of a chip like that and then like this separate board for the testing. Let's see, it actually looks like it's a completely designed tool specifically for the job actually. Wow, that's pretty cool. I'm impressed already. So we've got 1 ohm, 1 ohm, 1 ohm, 5.6 ohm, 1 ohm, 5.6, 1 ohm, 1 ohm. Okay, and then we've got a few 1 watt jobs here as well. That's cool. Pretty small wire. Oh no, it's 22 gauge. It's all right, I guess. Let's have a look inside. This actually looks quite well made, I'm going to say. I'm impressed, especially for the price. I mean, for the price, I'm going to have to double check. I swear this was $60. Maybe it was 160. I swear it was only 60 bucks. I'm going to have to go double check because that just is amazing. Damn it. Ah, that's so annoying. That is different on one side. Which means I don't know if it went like that. Oh, dude. Don't tell me these are going to fall out too. Oh man, I'm going to have to stop the video. I can't even put this back together without watching my video to find out where the freaking parts are coming out of. I'm not impressed about that. Sorry guys, I was going to shoot this all in one go, but I have to stop now to work out how to put this back together. I've got to watch my own video. Alright, that's that problem solved. I just wanted to make sure I couldn't put that back together in the wrong position and cause a short and damage it, so I went back over my video and it's working. I've checked it, so it's all good. I got everything back where it goes. Should have been more gentle. Anyway, so this is the underside of that board. Okay, there is flux residue absolutely everywhere in here. Quite typical if you have ever seen inside Chinese multimeters. Anyway, that's not going to affect the performance of this sort of thing. Looks like we're going to have a chip on a blob somewhere as the LCD chipset, multimeter chipset, whatever you want to call it. Looks like there's two separate power supplies in here. I would wager bet that I'm not sure if those 6 pins there are some sort of a chip and that's controlling this, and that's the transistor that's switching it. Maybe this second smaller device is being switched by this transistor. I'm not sure. Is it even a transistor? I'd use a MOSFET. Yeah, 9013. It's 9013. Alright, well let's continue looking. Looks like there's some interesting stuff in here. Oh no, that's the jacks. Okay. Bit of solder. What? Oh, that. Yeah, right, okay. That didn't feel right. I turned the screw and it cracked and then it got loose all of a sudden. That's not usually a good sign. In this case, it doesn't matter. Like I said, I don't think this thing was incredibly expensive, so if I accidentally slipped and broke it, it wouldn't be the end of the world. I wouldn't be spewing like the other week when I broke my DCA Pro. So we've got one pot here. I'm not sure what that adjusts. I'm not going to turn it. I think that's actually something to do with the high voltage, to be honest with you. It's got traces going back over to the high voltage section. There's your high voltage doubler capacitors and diodes. So it's not just a step up transformer of a rectified output, it's got some voltage doubling by the looks of it. That's how I would do it for this sort of thing. It gives you a bit of current limiting, and at the same time you don't have to worry about winding the transformer too intensely and arcing over inside. It just makes sense. Alright, screws are out. So there you have it. That's all she wrote. We'll have a look and see. Yep, chip on a blob. I'm just going to straighten these guys up whilst I'm in here. Why not? Not too bad already. You beauty. So that's what you get, and there's another pot there. So underneath this LCD is a chip on a blob. Should I chance it? No, I'm not going to do that. I don't know if you can see in there. There it is. There's the pads for a chip or a chip on a blob. So you could have either option. Anyway, that's all there is to it. I'm still quite impressed. I'm very happy with this. I mean, like I said, it was not expensive. I will pause this video once I've put this back together, and I'll go online quickly and I'll have a look and see exactly how much it actually cost me. And I'll let you guys know. I can tell you now, after using it for about 3 days, and after seeing inside it, it is definitely worth the money. I highly recommend buying this. Highly recommend it. If you need to match transistors and do basic tests on them, you know, yeah, this is useful. I still prefer the DCA Pro for more intense testing, but like I said, if you're just trying to match transistors, or you know, you want to just test breakdown, VCE, SAT, HFE, you know, to try and match them and make sure they're not fake, well, you know, this and a multimeter to check the capacitance, to work out how big the die is inside between the collector and emitter pins, like I showed in another video. That's a good way of telling how big the die is inside it. I mean, with an LCR meter, sorry. You know, yeah. You'd be surprised what you can do with limited tools if you know how to use the tools to your advantage. I won't lie, but having this and having the DCA Pro is obviously just awesome. It's a lot better, but yeah, if you're limited for money, get this. You'll be able to at least match your transistors. You can always do VBE with a multimeter and the capacitance check with a multimeter, you know. That's interesting. It says duoyi. Oh, that's the brand. Never mind. Alright, well, I'm going to put this back together. I'll just pause the video now and I'll find out how much this cost. Oh, I forgot my rotator assembly. It goes like that. Alright, I'll find out how much this cost for you guys. Alright, you're all going to be very happy. This is $62 on AliExpress. All you need to do is type in the brand, duoyi. They make quite a few different products. If you just type in that, you'll see it. Maybe type in transistor tester. It'll pop straight up. Yeah. Oh, I've left screws, haven't I? No, I haven't. Yeah, it'll pop straight up. So $62, guys. You can't go wrong there, seriously. That is just wonderful. You know, maybe it cost 20 bucks shipping. I didn't have a look, but even if it did, that's still pretty good for what you get. And you guys have seen inside it with me, the build quality is there. you know, this is passing my standards, you know. I'm actually quite, surprised about the build quality, considering it's a $62 Chinese tester off of AliExpress, you know. These aren't even the AliExpress components that are in here. I can tell looking at them. Some of them are, but like these resistors and these resistors, these have come from DigiKey or something. I can tell because they got the thick coating around them. They're not the really thin coated cheap ones that you buy. Same with the transformers. I've bought a lot of stuff, you know, over my life and recently off of AliExpress. So I've got a good idea of what the Chinese stuff looks like, and yeah, this is a bit of a mix. This is pretty good. I'm honestly impressed for $62. Yeah. Very pleased. Highly recommend. Now, why do I have extra screws? Oh no, I don't. That's for the case. All right. There we have it. I'll finish putting this together off camera. Alright, there you have it. And the cover that it comes with, alright, comes with its own little cover, which is pretty cool. The cover, when you take it off, goes over the back. So, pretty cool. Anyway, that is my review of the duoyi dy-294 transistor tester. Something else to mention is that you can put external 6 volts in here, because you know it can source up to 2 amps collector current, and I'm not sure when you're testing 10 milliamps base current how much is getting pulled across the collector emitter junction either. You know, it could be even more, like 5 amps or something, I don't know. So that's quite handy, you know, because the double A's can, you know, you can get quite a few amps out of a double A, especially short circuit current, but they're still not going to last forever. So that's quite nice to see as well. Oh, something else I didn't mention, I'm sure it's quite obvious, but it has a hold function, so you can hold whatever's on the screen. But yeah, that is it. Oh, and I'm sure again you can work this out from looking at it. You've got every possible pin out there, but you've also got your TO3 style here, so you can put a TO3 style device in there and test it as well. That's pretty cool. And I've tested this, that actually fits perfectly in the hole. I'll just get one to show you quickly. Alright, got an NTE 185 here. We'll test it at 1 milliamp. Oops. That's not right. I thought this was a PNP. Oh, there you go. So it seems about right. Anyway, that's what it looks like with a TO3 device in there. And like I said, that actually does go all the way in. Not quite sure how I'm going to get that out now, but it's nice to see that you can make a really snug fit. Not sure that you'd want to do that all the time, but yeah. Alright, thanks for watching. I'll see you all soon.